Good day to our viewers at home. My name is Peter and I will be your mathematics instructor for today's class. And today's class is going to be on set theory. Set theory happens to be a topic, a very simple topic in mathematics. And when you understand the basics of what set theory is all about, then you'll be able to answer questions on that particular topic. Now, what is set? Set is a well-defined collection of objects or things. It can also be a well-defined collection of people. Now, an example is, let's say set P equals to prime numbers from 1 to 30. So if you list out the prime numbers ranging from 1 to 30, then you always agree that set P contains members that are what? That are prime numbers. Do you understand? Now, let's talk about some terminologies in set theory. And the first one we'll be talking about is elements of a set. When you talk about elements of a set, element of a set refers to what? Members of a particular set. Element of a set refers to members of a particular set. And it is denoted by this symbol. It is denoted by this symbol. So it is denoted by a symbol that represents E, which implies that what? This is a member of this particular set. Let's have, for example, we have set A to be having 1, 2, 3, 4. Now, you agree with me that 2 is actually a member of what? Of set A. So this is how it is written mathematically. 2 is a member of what? Of set A. Because 2 is actually found in what? Is an element found in what? In set A. What about 7? Can you find 7 in set A? Of course not. So what do you say? You will then say 7 is not a member of set A. Is not a member sign is that particular symbol E, but slashed. It's just like when you say is not equals to. So that's the same thing as is not a member of set A. So having done that, we move to the next terminology in set theory, which is number of elements in a set. In secondary school, many of us might not know this because we were not taught. Numbers of elements. Moving on to the next thing, numbers of elements in a set. When we talk about number of elements in a set, we are trying to talk about the cardinal number. That is, what are the number of elements in this particular set? That is, we listing out the element in that set, but giving it a particular number. And it is denoted by n into bracket A. That is number of set A. Now, let's go back to the first example I gave. I said set A has 1, 2, 3, and 4 as the element. Now, if you are asked to look for the cardinal number of this set A, the answer is going to be 4, because it contains 4 elements: 1, 2, 3, and 4. Let's take another example. Let's assume we have set B to have A, B, A, C, B. And you are asked to look for the cardinal number of set B. Then your answer is going to be 1, 2. This is A, which we've counted as 1 before. So we will skip the next one and move to the next one, which is C, which is 3. Then we have counted B already. So which means the cardinal number or the number of elements in set B is going to be 3. So if you have any question, you can always feel free to use the comment section to ask your questions. Going to the next one, we have what we call the subset. Subset. And when we talk about subsets, we are trying to talk about a set within another set. A set within another set, a set within another set. And what do we mean by that? Example, we have set A to give us 1, 2, 3, and 4. And we have set B to give us 2 and 4. You all agree with me that the elements in set B are gotten from elements in set A, which means that B is a subset of A. So kindly look at the symbol for subset. It is a symbol of in a shape of C. So that means that B is a subset of set A because the elements in set B are actually contained in set A. So having done that, this will actually give us this will lead us to another particular terminology, which is the power set. The power set is defined as the number of subsets in a particular set, that is number of subsets in a particular set. Now, the symbol is given as power set equals to 2. Now, remember this particular symbol. We actually got this from what? From the cardinal number. That is to tell you that the power set is going to be 2 raised to power the cardinal number. Now, let's go back to the first example I gave initially. We said set A is what? 1, 2, 3, and 4. Now, if you are being asked to look for the power set, looking for the power set means that you are looking for the number of subsets this particular set can contain. Now, using that formula, n of A, which is the cardinal number, and don't forget what I said the cardinal number is. The cardinal number is the number of elements in a particular set. Now, what is the number of elements in this set? It is 4. So therefore, the power set is going to be 2 raised to power 4, which is 16 subsets. That means that the number of elements this particular set, the number of subsets this particular set can have is 16, which I'm going to list out the subsets right now. Now, look at the next side of the board and check the answer. Another way you can get the number of subsets in a particular set is when you write out those subsets out, where we have 1, 2, 3, 4. You've written out the individual elements out. Now we pick the first two, 1 and 2, that's another subset. 1 and 3, 1 and 4. We write 2 and 3, 2 and 4, 3. If you read through, you will see where we have 1, 3, and 4. Then take note that an empty set is also a type of is also an element of this particular set. Then we have the set itself, which can either be written as capital A, or you write the element in that particular set out, where we have this. Now, if you count the number of subsets you have written out, you will see that it is 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, and 16. That means that our solution using the formula for power set is accurate. Now, the next thing we are going to move on to is going to be the types of sets. Basically, we have 5 types of sets. We have the empty set, the finite set, infinite set, equal set, and the singleton set. Now, let's take one after the other. When we talk about an empty set is also the same thing as a null set or a void set. What that is trying to say is it is a set that has no particular element. It has no element in it, and it is either denoted by this, a 2 curly bracket without anything inside, or this particular sign. Now, moving on to the next thing, a finite set from the word finite, from the word let's go to infinite set. Infinite set, you say infinity. And when you talk about infinity, it means something that is continuous, that has no end. Now, come back to finite. What is a finite set? A finite set is that set that has an end. Let's assume we have set A and you have written A, B, C, D, dot, 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 and you said, okay, the end point is Z. Then this is a finite set because it has an end point Z. Now, let's also talk about the infinite set. Let's assume we have set B. A infinite set is that set that is continuous, that has no end. Just like when we have 1, 2, 3, 4, dot, dot, dot. It has no end, which means it is continuous. Moving on to equal set. Equal set is that set that have the same element contained in each of them. What do we mean by that? Let's take, for example, set C is having 1, 2, 3, and 4, while set D is having 2, 3, 1, and 2. You 3, 2, 3, 1, and 4. You will agree with me that set C is equals to set D. Because of what? The number, the elements that are contained in set C are also contained in set D. But if you had add element 5 to set D, that means that set D, C is not equals to set D. But no matter the arrangement, as long as they have the same elements contained in each other, then it is a it is an equal set. Then the last one is a singleton set. When we talk about a singleton set, we are talking about a set that has only one element in it, which is, an example is 1. This is a singleton set. Let's assume we have 0. That's also a singleton set. Let's assume we have 11. That's also a singleton set. Now, this is an assignment, or you use the chat box. What type of set is set E that has this? What type of set is set E that has this? Moving on to the next thing. Many would have asked, sir, you did not talk about universal sets, union sets as types of sets. Yes, I did not, because they are not types of sets. They are the relationship between sets. That is, how do you relate a set with another set? And here we have 5, which I've written out here. The first one is the universal set. The universal set happens to be the parent set, and it is denoted by this symbol, a coiling U. Now, what does it mean? It means, let's assume we have your surname is Ajanle Koko. Anybody born of Ajanle Koko is Ajanle Koko is the universal set of anybody born in Ajanle Koko. I don't know if you understand what I said. What I'm trying to say is all the elements from this particular family, Ajanle Koko, are what? Are present in the family Ajanle Koko, which makes the Ajanle Koko the universal set of the family. Or in short, the surname happens to be the what? The universal set of that particular set. So let's assume we have the universal set to be what? 1, 2, 3, 4. So these are the members or elements of the universal set. Now, moving on to the union set. Union set happens to be, is the same thing as saying the summation of sets. Union set is happens to be summation of sets, and it is denoted by a small u. That is, A union B means addition of the two sets. We have set A to be 1, 2, 3, and 4, and we have set B to be 2, 4, 5, and 6. Then A union B is going to be a summation of the two sets, which is 1, 2, 3, 4, 5, and 6. We will not write 2 twice because you take the element as 1. Let's move to number 3, which is intersection set. Intersection of a set means an element that is common in 2 or more sets. An element common in 2 or more sets. What do I mean by that? Moving on to, we have set A, we have set B, then we have set C. Set C is 2 and 5. Now let's take a first question. A intersection B. The symbol is small n. While for union, it is what? Small u. Now intersection means something common. Now let's do A intersection B. A intersection B means what is common in A and that is also common in B. That is the intersection. Looking at it, you have 2 and 4, which are common. So the answer for that is going to be 2, 4. Now let's take another example. A intersection B intersection C. It means when you compare 3 elements and 3 sets together, what is common? A, B, and C. If you look through, you will see that 2 is common all through the set. So 2 is the answer for A intersection B intersection C. And we call this type of answer a singleton set because it has only one element. Moving on to the next one, complement of a set. When we talk about complement of a set, we are talking about when you subtract the element from a particular set from the universal set, anything left in the universal set will be the complement of that set. The English might be too strong. All I'm saying is, let's assume we have the universal set to be 1, 2, 3 to 10. You see that I've written an example of a finite set because it has an endpoint. And we have set A to be 1, 2, 3, and 4. I have been asked to look for A complement. And what did I say? I said A complement happens to do with when you subtract all the elements of A from the universal set, anything that is left in the universal set is the complement of set A, which is universal set minus A. When you subtract all these elements, that means that 5, 6 to 10 will be left, which makes 5, 6, 7, 8, 9, and 10 to be what? A complement. If you need more explanation on that, of course, we are always ready to assist on that. While lastly, we have the disjoint set. Disjoint set is just the opposite of intersection set. Intersection set, we said it is when an element or when two or more sets have a particular or more elements in common. While disjoint set is when two or more elements has no two or more sets has no element in common. When two or more sets has no elements in common, and that is going to be well represented in a Venn diagram, which will be going to any moment from now. But before we get there, we need to talk about two particular subtopics in set theory, which some teachers don't really touch. And the first one is going to be difference between sets. Difference between sets from the word just means subtraction of two sets. We have set A minus set B, or you can have set B minus set A. So that is just what we are talking about. Now, when we say A minus B, what does that imply? When you have a universal set, it implies that it is A intersection B complement, or you say B intersection A complement. And this can also be written as B over A. Likewise, this can be written as what? A over B. Now, let's take for example, we have the universal set to be 1, 2, 3, 4, 5, 6. Most times we don't make use of universal set depending on how your question comes. So let's take this off and let's use set A and set B directly. Let's assume we have set A to be 1, 2, 3, 4, and 5, and set B is 2, 1, 4, 6, and 8. And you are asked to look for A minus B. A minus B means that subtract the elements that are common in A and B. Take away the element common in B from A. A minus B means you want to take off the elements that are in B from A. You've taken 2, you've taken 1, you've taken 4. Nothing else is common. It means that 3 and 5 will be the answer for A minus B. 3 and 5 will be the answer for A minus B. When you now talk about B minus A, it means you want to subtract the element of A from B. That is doing the same thing. A is gone, 1 is gone, 2 is gone, 4 is gone. Which means 6 and 8 is left in set B, which gives us the answer for that particular question. Now, if you have any other question, you can do where to ask. There is no issue on that. Moving on to the next one, we have the symmetric difference of sets. Symmetric difference of set is just like saying A triangle B, which is symmetric difference. This represents the symbol for symmetric difference, which is equals to what? A minus B union B minus A. There are some cases that you might not see your option to be A minus B or union B minus A. Then you either see it as A intersection B complement union B intersection A complement. I hope you understand what I've written. So you can do it to just give this particular question a universal set of 1 to 10. Then you can try out this formula to moving to Venn diagram. Now this is how Venn diagrams look like. Now we have diagram A, diagram 1, having two sets, and the two sets have they intersect at a particular point, which we don't know. How do we know if a set intersects or if two sets intersect? It means the circles will cross each other, which means that at this point the element, any element written here is present in set A and at the same time is present in set B. Do you understand? Which will give us an issue to what the element in set B or set A can be. Now, that means that the element in set A will be what? 1, 2, and X, while the element in set B will be what? A, B, C, and X. I'm just trying to cite an explanation here. So, moving on to the next one, we have three sets, where set A and set B and set A and set C intersect. Tell me, why is set B not joined to set C or set A or to the two together? Leave your answer in the comment section. This is a question in JAM 2011. Now, this is a set question that says, in a survey of 50 newspaper readers, 40 read Champion and 30 read Punch. How many read both papers? Now, the first thing you need to do in set theory is list out the given parameters. And the first one is, the universal set is what? 50. Because they said in a survey of 50 newspaper readers. So we have the universal set to be 50 readers. And we have the number in Champion, those that read Champion newspaper, to be what? To be 30. And the number of those that read, to be 40 rather. And the number of those that read Punch newspaper to be 30. And the question says, how many read both punch and champion. That is that's P intersection C is X. Then we are looking for this. You can easily represent this in a Venn diagram. And P intersection C means that they actually intersect, which means the intersection part is going to be X. Now going back to what the question says, it said 40 read champion. The 40 that read champion means that they do not read only read champion, but they also read other newspaper, which can be in either the punch or outside, that is maybe daily and other newspaper. Now 40 read champion means that they are not alone, which makes us have 40 minus X here. If they had written 40 read champion only, then that means this 40 will be standing on its own. But because they've not used the word only, then X must be subtracted from it. The same thing applies to punch newspaper. That will be 30 minus X, which at the end of the day, you will have the numerator set to be what? 40 minus X. You sum up everything plus the X, that's the iteration, plus 30 minus X. And don't forget, what do we call our universal set? Our universal set is 50, where we have this one crossing each other, and we have 70 minus X, which at the end of the day, if you do your simple arithmetics, X equals to 20. So therefore, the number of people or the number of readers that read both papers is 20. So therefore, the number of readers that read both papers is 20. Now, if you are being asked to look for the number of readers that read only champion will be this particular one, which is 40 minus X. And what is our X? 40 minus 20, which is 20 as well. So numbers of people that read champion newspaper alone will be 20, while those that read punch newspaper alone will be what? 30 minus 20, which is 10. Kindly take note that in set theory, your answers are not meant to be negative, and they are also not meant to be fraction. Because when we talk about set theory itself, only if your question, it is not even possible. This is where we will stop our discussion on set theory. Should in case you have any question, you can always feel free to use the comment box, the comment section, and ask your question. We are always open anytime, any day. Thank you for trusting us. Bye.
Price, trusted authenticity, anytime, any day.